Good morning everyone. This is Hafiza. I'm studying BTech in Srinivasa Ramanujan Institute of Technology under the stream of Electrical, Electronic and Engineering. Today I'm here to give a presentation on and this is synchronous condenser. Now I'm going to another slide. And now I'm going to introduction to synchronous condenser. A synchronous condenser is a type of synchronous machine that operates primary for reactive power compensation. It can be provided dynamic voltage support in power systems, helping to stabilize grid operations. Unlike traditional condensers, a synchronous condenser can also absorb the generate reactive power based on the grid requirements and some key points and some key components of synchronous condenser. The main components of a synchronous condenser include the rotor and stator, excitation system and other control systems. And the rotor is usually with depending on design requirements. The excitation system maintain the necessary magnetic field strength for reactive power generation and absorption. And this is example picture of synchronous condenser, and this is AC system, and this is coupling transformer, this is siblings. Under one is three phase field winding, and this is back to back converter. And next is defined synchronous condenser. An over-excited synchronous motor running and no load is called the synchronous condenser. It is also known as the synchronous capacitor or synchronous compensator or synchronous place modifier. And this is example picture. An asynchronous motor can deliver or absorb reactive power by changing the DC excitation of its field winding. It can be made to draw a leading current from the supply with the over excitation of its field winding, and therefore it supplies the lagging reactive power. And next one is under excited synchronous motor. When the synchronous motor is under excited, then it draws a lagging current from the source. Hence supplies a leading reactive power or absorbs a lagging reactive power. Therefore, the current drawn by the synchronous condenser can be changed from lagging to leading smoothly under excited by varying its excitation. Another one is over-excited synchronous motor at no load. When an over-excited synchronous motor is operated at no load, it takes a leading current and hence behaves as a capacitor. As the over-excited motor draws a leading current from the supply, it absorbs leading reactive power and delivers the lagging reactive power. When such a machine connected in parallel with the induction motor or the another inductive load, that is a device that operates at a lagging power factor and absorbs the lagging reactive power. This lagging reactive power demand is met by the synchronous condenser. Thus, the inductive load does not take the lagging reactive power from the supply, and the current factor of the plant has been improved. The synchronous capacitors, that is over-excited synchronous motors on no load, are installed in an electrical power systems only for power factor improvement of the system. The synchronous condensers are economical in large sizes than the static capacitors. And this is working principle of synchronous condenser. The synchronous condenser functions similarly to a synchronous motor with a rotor and a stator configuration. It operates at a synchronous speed. It can be adjusted its power factor by controlling rotor excitation. By changing the excitation levels, it can be either provide capacitive and inductive reactive power to the grid. Advantages of synchronous condenser: power factor correction, voltage regulation, stability improvement, controllability, overload capacity. And disadvantages of synchronous condenser: high initial cost, operational losses, maintenance requirements, size and shape, size and space, and another startup time. And these are the examples of a synchronous condenser. Synchronous condensers are commonly used in power plants to regulate voltage and improve the system stability. They are also employed in industrial settings to enhance power quality and efficiency. Additionally, they can be integrated with renewable energy sources to help manage and support grade the reliability. And these are some example picture of synchronous condenser. And this is conclusion part. Synchronous condenser are essential for maintaining grid stability and improving power quality. They offer unique advantages are over traditional reactive power solutions and there is some disadvantages. Their role in modern power systems will be continue to expand, particularly with the rise of the renewables. Thank you for giving this opportunity.